Hi, welcome back to Math 9. We are just done with quadratic equations. Now, we will proceed to quadratic inequalities. But before we deal with quadratic inequalities, let's recall the properties of inequality that you have had already in the previous years. So, Lesson 3.88 will present to you the properties of inequality and the ways in writing your solution set. Okay, so let's say for any A, B, C element real, the following hold true. Number 1, trichotomy. Let's abbreviate this as this only. This property says that if A is not equal to B, then either A is less than B or A is greater than B, but not both. Again, if A is not equal to B, then either A is less than B or A is greater than B, but not both. For example, suppose I have here x plus 1 not equal to 5. This one implies that x plus 1 less than 5 or x plus 1 greater than 5, but not both. It's just saying it cannot be both night and day, or you cannot be both here and there. The next property is transitivity. We'll abbreviate this as transitive property of inequality. This states that if A is less than B and B is less than C, then A should be less than C. Also, if A is greater than B and B is greater than C, then A is greater than C. Obviously, example, if 2x minus 3 is less than 5 and 5 is less than 1 minus 2x, then 2x minus 3 is less than 1 minus 2x. Next property, addition property. Or we have this addition property of inequality. This property says that if A is less than B, then adding a constant to both sides will let us retain the sense of inequality. So, A plus C is less than B plus C. Also, if A is greater than B, then A plus C is still greater than B plus C. This property allows us, for example, to solve the solution set of this linear inequality. I can add negative 2 to both sides, so I get x plus 2 plus negative 2 greater than 3 plus negative 2, and the sense of inequality is preserved, giving this x greater than 1. X plus 2 greater than 3, you add negative 2 to both sides of the inequality. It will not change the sense of inequality, and you will now have here x greater than 1. The next property, multiplication. We will abbreviate this as MPI. For this property, let's have two cases. Suppose A is less than B and C is positive, then multiplying an inequality by a positive number will not change this sense of the inequality or the direction of the inequality, which means A less than B times C will give me AC still less than BC. However, if A less than B and C is negative here, then what happens here will be this negative number you multiply to this given inequality will reverse the sense of this inequality. So, instead of having A less than B in the answer, we will now have AC greater than BC. Let's have an example of the last property, 2x less than 6. Multiplication property allows me to solve for the value of x in this inequality, and I can just multiply this by the multiplicative inverse of this coefficient here. So I get here 1/2 times the quantity 2x less than 6 will give me x less than 3. This sense or direction is preserved. However, for example here, I have a negative 2x less than 6, for example. I multiply this by the multiplicative inverse of negative 2. So I will get a negative 1/2. Then this gives me a change in the direction of inequality because of this negative number. And then minus 1/2 times minus 2 will give me a 1. So I have an x on the left hand side, and minus 1/2 times 6 is negative 3. So the direction of the inequality has been reversed. Okay? Now, you can see this very clearly. Let me give you another example of this property. Here, we know that 5 is greater than 3. If we multiply this inequality by a negative number, let's say negative 2, then immediately I will reverse this direction even before I will write my answer to avoid confusion. So, negative 2 times 5 will give me negative 10, and negative 2 times 3 will give me negative 6. Okay? So, we have these properties that you have already been accustomed to when you were in the lower years. To review, to recap, let's say for any ABC element real, all these properties will hold true. So these are the properties of inequality that you should always remember. Most of the time, we will be using properties 3 and 4 in solving inequalities. Now, the next portion of this lesson 3.8a is, as we mentioned, ways in writing the solution set. For example, you have solved an inequality. Let's take a case of a linear inequality that you are familiar with. X plus 2 greater than 5. Applying the laws of inequality, we can solve the value of x here. So, I add negative 2 to both sides. I'm allowed to do that because of addition property of inequality. And I can get here, this one is retained. I would advise you to write the direction first before you do the other steps. So this is addition property. It will not change the direction or the sense of the inequality. Now I have here x greater than 5 minus 2 is 3. Okay, let's write the solution to this inequality in several ways. I will base my solution first to this graphical form. Okay? So, x greater than 3 means all x should be to the right of 3, which means I'm going to the right here. Now, this is open because this is a strict inequality. So, this must be open, which means the solution to this inequality does not include 3. So, I start immediately after 3 going to the infinite direction to your right. Okay? So, this one is my graphical form. Okay? That's the graphical form. And I will write it in the next form from 3 up to positive infinity. This is what I term interval form. Notice this symbol here. This open parenthesis here means that it doesn't include 3 in the solution. So this is an interval from after 3 going to positive infinity. I can write this more formally as x such that x greater than 3. This will be my set form. Okay? Suppose I will have a solution which is going to the left. Let's say, suppose I will have here x less than 3. Then the graphical form will be similar to that, except that the direction is going to the left. So, this one now is the graphical form. and I will now have this my interval form, and I will have here x such that x less than 3, my set form. So let's take a look at that again. X less than 3 will give me that direction. Then this is the interval form, and this is the more formal set form. Now, let's just illustrate. For example, I have here x between 2 and 5. So I can graph that and say 2 here and 5 here. This is x greater than 2 at the same time. X is less than 5, meaning x greater than 2 going infinitely to the right, and x less than 5 going infinitely to the left. And they will have this intersection, okay? Here we have the graphical form of this one here, and I can have the interval form 2, 5. This is open, this is open. So this is a strict inequality, meaning it doesn't include these endpoints there. It is not correct to write 2, 5. Writing the solution set of inequality does not allow you to do this. This is pointless. This is the interval form, okay? And this is a strict inequality, meaning 2 and 5 are not part of your solution. Furthermore, suppose I have here, I will have the endpoints be part of your solution. Then what we have here will be 2 and 5, and 2 will be included in the solution, 5 will be included in the solution, and I have this one here, which means I have a not strict inequality, and I have this closed interval from 2 to 5, which means 2 is included in the solution, and as well as 5 included in the solution. So this is a strict inequality. This is a non-strict inequality, where this one is in graphical form, this is in interval form. This will be the set form. I'll make it more formal, so I can write x such that x between 2 and 5. Here I can have x such that x is greater than or equal to 2 but less than or equal to 5. So I said this is a strict inequality. This is a not strict inequality. I can have a hybrid of these two. So I can have here one is open and the other one is closed. So I can have this, and I will write that as open at 2 and closed at 5. So this is a half open, half closed interval. Similarly, I can have closed at 2 and open at 5. And this is still a half open, half closed interval, and I will write it as close at 2, open at 5. Okay, so there you have it. We will be using these forms when we write solutions to our quadratic inequalities. Thank you. Have a good day.